This is a walkthrough of the X-660 and X-880 shaft alignment systems. We're also going to show an additional feature called the base-bound, bolt-bound application within couple 6. Let's get started. Let's talk about installing the hardware, part of setting up the X-Series equipment. Once you open up the box and you remove the foam insert that holds the tablet and the accessories, you want to grab your brackets with posts installed and your 2 chains. Both units have different brackets. For the X-660, it comes with the black aluminum bracket, and for the 880, it comes with the stainless steel bracket. To install the chain, simply slide the pin on at a 45-degree angle and then slide it into the housing of the bracket. When installing the bracket onto the shaft, you want to ensure that you have enough clearance for the heads of the alignment unit to be able to rotate, whether it's 360 degrees or less. Best way to do that is get it closer to the coupling. The end of each chain has a magnet on it. It allows for connecting the extra part of the chain back to the bracket to allow for free movement and easy movement of the system without interference of the chain. Ensure that you keep the brackets tight but not too tight, because they have to be able to move for the next step, which is installing the laser and the target heads. If doing an alignment on a shaft less than 1 inch, use this adapter, which goes in between the chain and the shaft opposite of the bracket. Now let's install the heads onto the bracket posts. You want to ensure that the target head goes on the movable or drive side of the coupler, while the laser goes on the stationary or the driven side of the coupler. Do not tighten them down, as you'll need to do a rough alignment of the heads in the next step. Regardless if it's the X-660 or the X-880, they both go on the exact same way. Laser on the stationary, target on the movable. Now let's align the heads. First thing you want to do is you want to turn on the laser. For the X-660, we're trying to align the 2 fan lasers with the 2 red horizontal lines on the target, and then moving those lasers into the target window. For the X-880, we want to align the 2 beam lasers into the 2 holes that are manufactured into the dust cap of the X-880 target. The reason we want to do this is getting us as close to center as humanly possible between the laser and the target. For the 880 and the dust cap, the distance in those holes is the exact same distance as the laser beams, which allows for an easy centering of the 880. The last part of the setup is to turn on the target. By simply clicking on the power button to the target, you are now ready to turn on your couple 6 software and begin the process. Once couple 6 opens, you have 6 tabs on the right-hand side. These tabs will not do anything until you actually start a project. On the left-hand side, you have settings and preferences, and you also have the project manager. In this instance, we're going to click on the project manager. In the top left-hand corner, you have 4 shaft alignment project options. The first one is create new machines and start a project. To the right is start a new project from a saved machine. You have open save projects, and then you have templates, new projects from saved machines. So what we're going to do today is we're going to start a new project on a new machine. First things first, you have to click on this icon first to get that green check mark before you can type anything in on the right-hand side. Make sure when you're writing what the machine's name is that you are consistent with whatever has been developed for that facility. Below, you can write more information if needed, or you can leave it blank. When you're done, you click on the Accept and Continue button on the bottom right-hand corner, which will open up the Save window. This is just like any other Windows format. You can change the file name, or you can just save it, and it'll save it automatically onto the tablet. Now that it's saved, you have access to 4 of the 5 tabs to be able to do the work. So we're going to start with step 1, dimensions and tolerances. Make sure you grab your tape measure for this one. We do need to take measurements in step 1. The A is where we're measuring from the middle of the coupler to the center of the post holding the target. Step B is from the center of the coupler to the center of the front foot of the drive or movable machine. Measurement C is measurement of middle of both feet on the drive or movable machine. Step D is the diameter of the shaft, and measurement H is the height of the center line of the shaft from the base plate or the bottom of the foot. Once you have the measurements, hold down your pen or thumb on the number box, and it'll open up a keypad, and you'll be able to enter in the numbers that you just recorded. Keep in mind, you need to keep your measurements within 1/8 of an inch. After entering in your measurements, you then want to check your alignment tolerances by RPM. You want to identify what the RPM of the motor, the drive, is set at. What this does is this sets your tolerances for both acceptable and excellent for offset angle and gap within this alignment. If you know that the OEM has a set tolerance level, you can actually click on the user tolerance and set your own acceptable and excellent. Other options within this step 1 is spacer shaft or dual coupler, bolt bound, base bound, vertical machine, and thermal growth. Inside the thermal growth window are 3 options. You can do thermal growth targets from foot value, you can do thermal growth from the coupler, or you can actually enter in the temperature. Most OEMs will provide you the thermal growth target from the foot value. So what is the compensation of that growth? And you're able to enter those right here. Sometimes you have to do that and get that measurement yourself and measure it by the distance that it travels, both offset and angular. If you have any questions, we have a separate video for this calculation. Step 2 is the alignment of both the target and the laser. We've already accomplished this in the very beginning of this video when we set up both the laser and the target onto the bracket posts. By aligning them and getting them as close to center with each other, this is the view that you're seeing. This does not have any effect on the alignment itself. This is just aligning the laser to the target. Now let's go to step 3. The soft foot check actually checks each foot to see if there is traditional soft foot. This will not check squishy foot, which is squishy foot means there are too many shims underneath the foot and it will move. No more than 4 shims under each foot. That is the known rule, no more than 4. It also cannot detect angular soft foot. What this is identifying is standard soft foot. It identifies which bolt we're going to start with, and when I click on record, it'll tell me now I need to loosen foot 1. Once I loosen the foot, I hit record again, and then it'll tell me to tighten foot 1. If there is a significant difference in the number, it will show by color whether we need to add shims. On the second foot, we're recording it with the bolt tight. And now it's telling us to loosen the bolt. We loosen the bolt, we hit record, and then we tighten foot 2. And we repeat this process as we go around. If the foot has soft foot, you will know because it'll show that there needs to be a shim added. If the shim needs to be added, you do not have to repeat this process and restart. You can literally click on the foot in question, add the amount of shim that it's informed you of, record it again tight, record it again bolt loose, tighten the foot, and check to make sure you remove soft foot. Now let's move to step 4. In step 4, we're going to sweep the heads around the shaft to identify the misalignment and where it's at. We have 2 options that we can choose from in this step. We have the auto sweep and we have the auto clock sweep methods. We're going to do the auto sweep first. You simply click on the start button to record and you start rotating the shaft in either direction. What this sweep is doing, it is recording touch points along this sweep up to 1,000 touch points for the entire 360-degree sweep that we are creating. Once you're finished doing the sweep, you can leave the head sitting in a certain position and it will automatically record. You'll get a pop-up for the measurement results and you click on accept. Here are your readings and here's how many points it recorded. Out of the 1,000, it recorded 236. Now let's do the same thing with auto clock. With auto clock, in each open area of white, we're going to record the target in that position. Every time you get to the next section, you hit record. Once you've recorded a minimum of 3 points within the auto clock, you can click done and it'll record that sweep. Click accept again. Now we have 2 recorded sweeps on the system. Now let's move to step 5. When you click on the shim button in the bottom right-hand corner of step 4, it'll take you to step 5, the shim and move screen. For the X-660, it's only going to show a single axis view. You have to rotate the heads to 3 or 9 to be able to view the horizontal. What you're working for is you're working to get the angle and offset numbers in yellow or green, yellow being acceptable, green being excellent. Next, rotate the heads to either 3 or 9 o'clock. This will automatically rotate the view to the horizontal view for the X-660. With the 880, you're able to view both the vertical axis and horizontal axis in the same screen. You do not have to move the heads in any location. You can keep them in the 12 o'clock or 6 o'clock position at all times and be able to do both the vertical move and the horizontal move while looking at it in live view. The goal of this alignment is for you to get within the tolerances of acceptable or excellent that were identified in step 1. Acceptable being a yellow color, excellent being a green color. If you have red, it's out of tolerance. The goal is to get both, either to get yellow or to get green. That's the goal. If you get yellow, you met the acceptable tolerances for that machine. If you get green, you hit the excellent tolerances for that machine. Once you click the unlock button, you now have live view for both the vertical and horizontal move. So as we move the system ever so slightly, we're able to align it and get everything green. Now we're ready to do, let's lock it down and see if anything changes. Once we've got all green or all yellow, for both vertical and horizontal, we want to go back to the bottom right-hand button is the remeasure button, and we want to remeasure. I'm going to use auto sweep for this measurement. This measurement, we're only going to go as far as the system will let us on the demonstrator we're using. Once you're done with the sweep, it will auto record, and now you're ready to look at what the system gave you. So this would be what our as left view should be. So moving to step 5, we can now see that we are well within tolerance and an acceptable alignment. Another feature included with both the 660 and the 880 is what's called the bolt-bound base-bound feature. If some of you have already been trained on, there is a way to do an optimal move if you're unable to move the feet in some type of direction, whether down or up, left or right. There's a way to do what's called the optimal move by utilizing the driven or stationary machine. Prime example that's on this screen is in the live view of the 880, it's telling me that I need to go down 3 thousandths in the front feet and down 6 thousandths in the back feet. Unfortunately, I do not have any, and let me repeat that, I do not have any shims under any of these feet. So now what I've got to do is I've got to create the optimal move by utilizing the stationary or the driven machine. The way to do this is go back to your home button, click on step 1. To start the bolt-bound base-bound application, you have to click on the bolt-bound icon on the right-hand side. It's going to ask for 2 new measurements. The first measurement is from the center of the coupler to the center of the front foot of the driven machine or the non-movable machine. The second measurement is the distance between both feet of the movable machine at center. Once you have those, you can click on Home, go back to the Measure Misalignment step, step 4, and we're going to do a brand new sweep. With this sweep, what we're doing is we're creating a brand new review of what the misalignment is so we can see it for both machines, not just the drive or the movable machine. And it will auto record. Once it auto records, click on Accept. Now that we've done our sweep, now we're going to click on the shim button and it's going to take us to a different view than what we had before. Step 5 now shows the vertical shim move for your base-bound option when you cannot go down on your movable machine. You can clearly see here the movable and non-movable or drive and driven machines with locks on the driven machine that we're going to be able to alternate. In order to go into live mode, you still have to click on the unlock button in the middle. And what it clearly shows is that we still have to take shims out from underneath our drive or movable machine, which we do not have. By clicking on the lock on the front foot of the driven machine or stationary machine, you're actually able to move that lock to the back feet of the drive or movable machine. And now we can see that we need to add shims to raise both the drive and the driven or the movable and stationary machine. By adding shims to both front feet of the drive and the driven or movable stationary machines, we were able to align the system vertically. To view the bolt-bound option, in the horizontal view, you click on the icon in the top right-hand corner and select horizontal, and then you have the horizontal view and you're able to do the same thing. Once you have aligned vertically and horizontally, you're now ready to do your final sweep. The suggestion here is to go back to Home. Before you do your sweep, click on Dimensions and Tolerances. Go back to Standard Machine. Go back to Home. and then go back to sweep and measure. By clicking back to the normal alignment screen instead of the bolt bound, it allows you to have the shim and move step 5 screen look normal for both the X-660 and the X-880. We're going to do our final sweep to make sure that our system is accurate. Like I said before, even with limited space, you only need 45 degrees. Once it hits blue, you can stop and go back to your 12 o'clock. I'm going to go to light blue. And now I'm going to go back. Now we're going to look at this recording or this sweep. We're going to go back to our shim and move, and in the 880 we'll be able to see both axes. We're green. Since we can clearly see that we're in excellent for both vertical and horizontal, now we're ready to print. Now all we have left is to print. What we want to print is we want to print our as found, the first reading we got, and the as left, the reading that we left it with, to be able to put in the records. To do this, click on the home button in the bottom center. We go to step 4, and we have to select our first rotation, which is our as found, and then click on the home button. You simply click on the print alignment report button. Ensure that it says Hamar Laser PDF printer right here in the center window, and click on print preview. When it pops up, it will show you the as found report, page 1 through 3. Once you close, either by hitting the X or the close button, it'll ask if you want to save it, the folder, to the reports folder. You say yes. Now we're going to print our as left. To do this, we go back to step 4. We unselect our first rotation, our first sweep, and we select our final sweep. We click back on home. We click on the printer icon. We check to make sure that we have Hamar Laser PDF printer, and we click on the preview print. This will show our as left report. We hit close. We save it to the folder. And now we are ready to close the software and walk away from this project. To do that, you simply hit File, Exit. It asks if you want to close the program. You say yes, and it'll bring up the file window once again. We now can save it as the same file name that we created. And there you go. Thank you for listening.